Hi everyone. This week we're going to be discussing 5 kinds of evidence that people often use to support claims. Remember that as we've been saying, not all evidence is of equal quality. So as we go along, we'll consider some of the strengths and weaknesses of each type of evidence, and we'll see that while some types are better than others, none of these are perfect. Let's begin by talking about common sense evidence, which is evidence based on opinions of what people in general believe to be true. So common sense evidence isn't really supported by anything concrete, other than the fact that people in general believe it. One example of a piece of common sense evidence is that being in the cold causes people to get sick. I don't think this is supported by scientific evidence, but people accept this statement as true because lots of people believe it. Another example would be you can't find a job with a psychology degree, which is clearly wrong. Right? It's accepted as true, not because it's supported by the data, but just because lots of people decided to accept it. Other examples include the death penalty deters murder, people are basically selfish, or when it comes to attraction, birds of a feather flock together, meaning that people with similar personalities attract each other. One strength of common sense evidence is that it takes the opinions of many people into account. So, by definition, common sense statements are generally accepted by lots of people as true. And presumably, things that are believed by lots of people are often true. However, just because a lot of people believe something, that doesn't make it true. We just discussed some statements that many people believe that are false. Now let's more formally look at some of the weaknesses of common sense evidence. And first, let's go over some more examples of common sense sayings. Some examples would be opposites attract, out of sight, out of mind, he who hesitates is lost, and 2 heads are better than 1. Well, we know through common sense evidence that when it comes to attraction, opposites attract, but what else do we know about attraction through common sense evidence? Well, we also know that birds of a feather flock together. Similarly, we know when it comes to long distance relationships, out of sight, out of mind, but also that absence makes the heart grow fonder. The same is true for the other ones as well. On the one hand, he who hesitates is lost, but on the other hand, look before you leap. On the one hand, 2 heads are better than 1, but on the other hand, too many cooks spoil the broth. So, the first weakness of common sense evidence, then, is that common sense statements are often contradictory. So, for many beliefs that people accept as true because lots of people believe in them, there is also a completely contradictory belief that is also accepted as true because lots of people believe in it. The reason this is a problem, then, is that common sense evidence can be used to support both of 2 competing claims, and thus it is not useful for determining which claim is correct. That is, even when we're comparing 2 completely opposite claims, we can often find common sense evidence to support each one. For example, if we wonder whether people with similar or opposite personalities are more likely to be attracted to each other, there are common sense beliefs to support both claims. And thus, common sense is just not very useful as evidence when evaluating a claim if it can be used to support pretty much anything. A second weakness with common sense evidence is that common sense beliefs that turn out to be false are seldom changed to reflect the new evidence. A good example has to do with changing your answer on a multiple choice question. So what do most people say? Is it a good or a bad idea to change your answer on a multiple choice question? A lot of people think it's a bad idea, that changing your answer on a multiple choice question decreases your grade. That is, this is the assumed effect, that you're likely to change your answer from a right answer to a wrong answer if you do change it. Instead, this is the actual effect that is true. That's supported by good quality scientific studies. Studies have shown that students are more likely to change their answer from a wrong answer to a right answer than from a right one to a wrong one. And so, changing your answer on a multiple choice question when you have a good reason to think that your original answer is wrong is more likely to help your grade than to hurt it. However, while this actual effect has been known for a long time, few people have changed their common sense beliefs and still think that changing their answer will hurt them. And so, when you see quotes like this one, use your common sense. Whenever you hear the word studies show outside of the natural sciences and you find that these studies show the opposite of what common sense suggests, be very skeptical. I do not recall ever coming across a valid study that contravened common sense. Well, just appreciate how silly this is. Now, that doesn't mean that whenever somebody says studies show, you should automatically believe that person, but lots of times well conducted studies do contradict common sense. And note that myth number one in the textbook, that people only use 10% of their brain, is another good example of a belief, which is false, that many people have that's based on common sense. So when you read that myth, keep in mind these issues with common sense evidence. Next, let's talk about anecdotal evidence, which is evidence based on unique examples, cases, or stories. The classic example of a piece of anecdotal evidence is something that begins with, "I know someone who," that is followed by a case supporting that claim. For example, someone might say, "I believe that aliens have visited Earth because I have a friend who said that she was abducted by aliens." And so, you're using your one friend's experiences as the basis for your belief in that claim. Testimonials are another good example of anecdotes. You're using one or a small number of people's experiences with a product as evidence that it is effective and that you should spend your money on it. The main strength of anecdotal evidence is that the examples are usually vivid, easy to remember, and convincing. So this is what makes anecdotal evidence so effective, that the cases and examples are so memorable and interesting. So when you see a psychic on TV who gives a reading that seems accurate, it appears to be very convincing evidence that they are indeed talking with the dead. Or when you read a testimonial that a product changed a person's life, you take that as good evidence that the product will also work for you. Next, let's discuss some weaknesses with anecdotal evidence. One weakness is that it is based on the most unique or uncommon instances rather than the typical ones, and thus may not generalize to other cases or people. For example, you'll often see commercials for diets show an anecdote of someone who lost a lot of weight on that diet. But even within those commercials, you'll see a disclaimer that says the results are not typical. So in reality, maybe 1 out of the 10 people who go on the diet or use this product to actually lose weight, they are the interesting, unique cases, they are the anecdotes, while the other 9 out of 10 people don't lose weight. The issue then is if most people who are on this diet don't lose weight, that would suggest the diet is not effective. And so relying on the anecdotal evidence would lead you to accept the wrong claim, that you going on a diet would allow you to lose weight. Another weakness with anecdotal evidence is that the report of the incident may be wrong. We've all heard of bizarre things that happened to one of our friends, cousins, siblings, nephew, but isn't it possible that a mistake has been made as one person tells the story to someone else? David Hume, who was a famous philosopher, once said, "No testimony is sufficient to establish a miraculous event unless the testimony be of such a kind that its falsehood would be more miraculous than the fact which it endeavors to establish." In other words, what is more likely? That aliens actually came to Earth and abducted your friend's, cousin's, roommate's older brother, or that the report of the event was wrong and it didn't actually happen? And then the final weakness is that anecdotes can often be found to support most claims, even contradictory ones. For example, you can find testimonials to support practically anything. If you want to know which of 5 different types of diets leads to the most weight loss, you could find testimonials to support all of them. So, how can you tell which diet is the best based on anecdotal evidence if all of them have supporting testimonials? Well, you can't. Or let's say you're having an argument with your friend about who is the better president, President Obama or President Trump. Well, you could probably find 1 or 2 examples or anecdotes of great things that each of them did during their presidency. So, how can you tell which president was best if we're just relying on anecdotal evidence? Well, we can't, because we can find anecdotal evidence to support both claims, indicating that anecdotal evidence is not very useful. The last weakness I'll mention is the ultimate cause problem, which is that it's impossible to tell from an anecdotal report if symptom relief was due to the treatment being effective or a number of other possible causes. Now, I made this term up, but why become a professor if you can't make up words, right? So, the idea is, let's say you get a headache, and your friend recommends that you put crystals on your forehead because he's heard that crystals have special healing powers. And let's say that 4 hours after the crystal application, your headache does actually go away. The question is, what is responsible for your headache ultimately going away? It is certainly possible that the crystals were responsible. But if all we have to go on is your one anecdotal experience, then there are other possibilities that we can't rule out. Here are some examples. First, it could be the placebo effect, which is experiencing symptom relief from a treatment because one expects to. So yes, the placebo effect is the tendency for people to experience symptom relief following treatments, regardless of the treatment's therapeutic benefit. Essentially, they expect the treatment to help them, and so it does. Studies on different symptoms have shown that a placebo, a pill that contains no chemical treatment, is effective pretty often, that it relieves symptoms like depression, ulcers, and migraine headaches about 30% of the time. So, if your headache goes away after the magnet application, it could just be a placebo effect where you felt better because you expected to feel better, not because the crystals have any actual healing properties. Another possibility is spontaneous remission, where the symptoms naturally go away on their own over time. So yes, the fact is that many people just feel better over time, even without getting a treatment. For instance, I'm sure we've all gotten headaches that just went away after a couple of hours on their own without us having to take Tylenol. So, if your headache goes away following the crystal application, it could just be that it would have gone away on its own without being treated, not that the crystals have any special healing properties. And then a final possibility is that the symptom relief is just due to other overlooked causes. So, let's say after your friend rubs crystals on your forehead, you go to the gym, take a nap, have dinner, and then as you're getting ready for bed, you realize that your headache is gone. Well, what was responsible? It could be that one of these other activities, the exercise or the rest or the food, was what caused your headache to go away, not the crystals. So, to summarize then, the ultimate cause problem is that there are lots of possible reasons for why someone might feel better. Did the person feel better because the crystals have some special healing powers? Or was it because of a placebo effect, where she thought that they'd be effective, so they experienced symptom relief? Or was it spontaneous remission, where the symptoms just went away over time? Or was it a separate activity like getting some food or sleeping that caused the headache to go away? The point is, it's impossible to tell what caused improvement in a single case, which is why anecdotes and testimonials are considered to be bad evidence for investigating these types of claims. And that's why scientific studies on the effectiveness of drugs, for example, are conducted using groups of participants, which does allow you to control for these types of things that I've mentioned here. The next type of evidence is statements from authority, which is evidence based on the beliefs of experts. The point here is that while we discuss the problems with relying on the beliefs of the average person when we discuss common sense evidence, experts in an area are presumably more likely to have accurate beliefs. When it comes to the claim that climate change is occurring, for instance, we might trust the opinions of climate scientists to Tim. And so, if an expert says something is true or not true, we can use that as evidence to accept or reject a claim. That's the basis of statements of authority. Now, it's worth pointing out that the quality of evidence from authority depends on the authority's knowledge, reliability, credentials, etc., and whether it's relevant to the topic. In other words, is this person actually an expert, and if so, is their authority relevant to the topic? So don't confuse fame or popularity with being an expert, and don't confuse expertise in one area with expertise in an unrelated one. For example, I've heard about YouTube videos where they asked all the Miss America beauty contestants whether they believed in evolution, and something like 98% of them said no. Well, if you asked biologists with PhDs, who are legitimate experts, whose experience is relevant to the topic of evolution, you'd probably get the opposite response, with 98% saying yes. So, which of these experts are you going to believe? As another example, if you've seen the movie Waterboy, are you going to believe Mama or the biology professor? The main strength of statements of authority is that experts probably do have more accurate opinions than the average person. So it would be impossible to go through life without listening to experts. They are more likely to be right than non-experts and are usually better judges of the quality of relevant information. So if a doctor recommends that you take 2 pills per day and don't drink alcohol with your medication, it's probably a good idea to follow her advice. However, just because someone is a proclaimed expert, that doesn't make him or her right, especially if their opinions are based on faulty evidence. So experts are sometimes wrong, just like the rest of us, and if their beliefs or opinions are based on faulty evidence, or as we discussed, if they aren't actually experts in the area, then their opinions would be considered poor evidence. Another weakness, authorities on a subject often disagree with each other, and without examining further evidence, there's no way of determining who is right. So for most topics, even scientific ones, you're going to find experts who believe competing claims. I'm sure you can even find some psychologists who believe in some of the myths in the 50 Myths book. And when discussing topics on the news, shows love to have two experts come on that disagree with each other. The point is that in these examples, each side is supported by evidence from authority, because at least one expert believes in each claim. The point then is that it's impossible to tell which claim is right using evidence from authority when you have experts who believe both claims. The final weakness is that authorities are rarely questioned, even when they are clearly wrong. The Milgram study, where people delivered what they thought were electric shocks to a subject because they were told to do so, does a good job demonstrating this issue with evidence from authority. In this study, an expert-looking researcher told participants to press a button to deliver electric shocks to another participant when they failed to answer a question correctly. The finding was that regular, ordinary people did this even when the other person was unconscious. So even though we all know it's wrong to deliver shocks to people for answering questions wrong, let alone unconscious people who can't answer questions, we follow the expert's advice and do what they say. The same thing is true in everyday life. If an expert says something, we often accept what they say as true without questioning it, even if it appears sketchy to us. Okay, that's all I have from this PowerPoint, but there's a second part 2 video on this topic on Canvas.